Alright, ladies and gentlemen, this is Mr. Anderson for Kellogg Community College at the 10th video of our work here with Math 121 Final Exam Review. So let's get into some more simplifying radicals. One of the cool things that this tests you on is to see what you can and can't do. And there's a property that you can add these similar square roots just like you could add 2x plus 7x, which would be 9x. So 2 square roots of 5 and 7 square roots of 5 is 9 square roots of 5. In terms of multiplying here, we're going to distribute the 3 square root of 5 to each of these here. So this becomes 3 square roots of 25 when I multiply that inside. And this becomes 3 square root of 10. Now this makes 3 times 5 minus 3 square roots of 10. So 15 minus 3 square roots of 10 is our answer. And we wouldn't be actually doing any other factoring because that would get us back to this right here. So that would be our final answer for problem number 39. Okay, let's take a look at number 40 here. Now 40 is really important if we're going to be looking at to clear denominators here, because we're going to FOIL this. The square root of 6 times square root of 6 is square root of 36. Square root of 6 and square root of 8 is negative square root of 48. And there we go. This is going to be the positive square root of 48. And this here is negative square root of 64. So this is 6 minus 8. The answer is negative 2. Because in a FOIL, when you have like this difference of the same terms, you see what happened there. We had a cool little simplification. Now we're going to solve the equation here. Before I actually take the square of both sides, I make sure to add my 5 to both sides. So I got the square root of y plus 1 is equal to 13. Then what I'm going to do is square both sides. So I'll put my little parentheses around each of these, put a little square there. So I got y plus 1 equals 169. That's 13 times 13. And then we subtract 1 from both sides. Y is equal to 168. So 168 is my answer. And you can plug that back into the problem to see if you're right, because 168 plus 1 is 169. Square root of 169 is 13. 13 minus 5 is 8. Checks. Okay, let me move the screen up a little bit more, and we'll get the next couple of problems in here. Okay, got 3 of them in there. Okay, so let's take a look here. Solving the equation, well, to get rid of the cubic root, I'm going to basically cube both sides. And one thing I'm checking here is, do you know what 3 cubed is? 3 times 3 times 3 is 27, so x minus 2 equals 27. X is equal to 29 if I add the 2 to both sides. And I can check the problem out for x equals 29 by plugging that back into this expression. 29 minus 2 is 27, cubic root of 27 is 3, so it checks out. Now what we're going to do is we're going to perform some following operations using the imaginary number I. Now 43 and 44 are really great to do back to back, because this, 43, is not a FOIL problem. It is a subtraction problem. So you're going to write out 5 minus 4i, distribute the negative, to make 3 minus 2i. So you combine your whole numbers, 8. You combine your imaginary numbers, minus 6i. So you'll notice that this is not, I repeat, not a FOIL problem, but this one is. This one you'll do your cables. 2 times negative 3 is negative 6. 2 times negative 5i is negative 10i. And 9i times negative 3 is negative 27i. And then this is the important one here. This is 9 times negative 5. This is negative 45. I times I is I squared. And there's a little principle that I squared is equal to negative 1, because I is equal to the square root of negative 1. So if you square this and square this, you get this. So this gets transformed into negative 6 minus 10i minus 27i plus 45, because this is the same thing as negative 45 times negative 1. Now what we're going to do is some simplification. The negative 6 and the 45, that makes 39, because you subtract the 6 from the 45. And this is going to make a negative 37i. And that's as far as we can go after you do the FOIL problem for problem number 44. And, wow, that's the end of the ditto, so, or worksheet here. So that's a nice little short one. Thank you for watching.